The most distant human-made object in space, NASA's Voyager 1 spacecraft, continues to amaze us more than 45 years after its launch. It has traveled far beyond the original mission's expectations, crossing into interstellar space, the vast expanse between stars, and is still sending data back to Earth using technology that is older than the cassette players that were popular at the time of its launch. It's an incredible feat. What's even more remarkable is that Voyager 1 recently made a groundbreaking discovery in the far reaches of space that has sent shockwaves through the scientific community and captured the imagination of people all around the world. What did it find? And how could this discovery change everything we thought we knew about space? Let's step back for a moment to understand just how revolutionary this mission was. In the late 1970s, two of the most ambitious space missions in history were launched, missions that would lay the groundwork for the modern era of space exploration. At the heart of this bold new era was a visionary at NASA's Jet Propulsion Laboratory, Gary Flandreau. Using just a pencil and a 20th-century engineering tool, Flandreau uncovered something extraordinary. He realized that, for the first time in human history, four of the solar system's gas giants, Jupiter, Saturn, Uranus, and Neptune, would align in such a way that a spacecraft could use their gravity to accelerate and gain speed, cutting down the travel time to these distant worlds. This alignment was a once-in-a-lifetime event. It only happens once every 176 years, and it provided a rare and unprecedented opportunity to explore the outer solar system in ways that had never been attempted before. But there was a catch: this opportunity was fleeting, and NASA had to act quickly. In the summer of 1977, NASA launched two identical spacecraft, Voyager 1 and Voyager 2, just 15 days apart, hoping to take full advantage of this cosmic alignment. These twin spacecraft, although designed for an ambitious mission, would go on to accomplish far more than anyone could have anticipated. Today, more than 45 years later, they continue to send data back to Earth from the outermost reaches of the solar system, surpassing all expectations. Originally, the Voyager missions were designed to last only 4 years. But these little probes, each no bigger than a Volkswagen Beetle, continue to defy the odds. They have become the farthest spacecraft ever sent from Earth, traveling over 14 billion kilometers from their launch point. And despite the limited technology they were equipped with back in 1977, just 69 kilobytes of memory, a tiny fraction of a modern smartphone, Voyager 1 and Voyager 2 have managed to achieve one breakthrough after another. The Voyager spacecraft sent back stunning images of Jupiter's and Saturn's moons, revealing active volcanoes and icy worlds, phenomena that were previously unimaginable. In 1986, Voyager 2 became the first spacecraft to approach Uranus, and 3 years later, it became the only spacecraft ever to fly by Neptune. Their discoveries changed the way scientists thought about the gas giants, their moons, and the outer regions of the solar system. These probes' journey, however, was not without its challenges. They had to perform gravity-assisted flybys around Venus, a maneuver that had never been attempted before. They traversed the asteroid belt, a dangerous and uncharted territory, and survived in a space environment where technology was primitive by today's standards. Voyager 1, for instance, relies on onboard computers that have just a fraction of the processing power of modern devices. Data collected by the probes was stored on 8-track recorders, yes, just like the old tapes, before being sent back to Earth using a transmitter that uses only 20 watts of power. To put that in perspective, that's about the same energy used by a standard light bulb. But the true wonder of the Voyager missions lies not in the technology they used, but in the discoveries they made. Both spacecraft made it through their flybys and continued beyond the outer planets, pushing further into the unexplored unknown, reaching distances never dreamed of when they first launched. As they ventured farther away from Earth, they began transmitting data from beyond the confines of the solar system, data that would forever alter our understanding of space. Voyager 1's most remarkable milestone came on August 25, 2012, when it crossed the boundary of the solar system, entering interstellar space, the region between stars, far beyond the influence of the Sun. This moment was historic, marking the beginning of a new chapter in human space exploration. But what was even more extraordinary was what came next. Scientists had expected the transition from the solar system into interstellar space to be a sharp, clear-cut event, marked by an immediate increase in cosmic rays, high-energy particles from outside the solar system. But when Voyager 1 crossed into interstellar space, the data it sent back was puzzling. Instead of the anticipated sharp increase in cosmic rays, the spacecraft detected an increase in plasma density, an unexpected finding that left scientists scratching their heads. Moreover, the magnetic field didn't shift as expected. The Sun's magnetic field was supposed to give way to a different magnetic field dominated by interstellar space, but no such clear change occurred. This led to one of the most significant debates in modern space science. Did the interstellar medium, the vast region between the stars, behave differently than we thought? Was the transition into interstellar space not as distinct as we once imagined? Scientists proposed several theories, including the idea that the magnetic fields of the solar system and interstellar space might be aligned in a way that created a smooth, gradual transition, rather than a sudden cut-off. This idea suggested that the forces shaping the cosmic environment around us were far more complex than we had realized. But the mysteries didn't stop there. As Voyager 1 continued its journey farther from the Sun, its instruments picked up unexpected fluctuations in plasma density. Interstellar space, it turned out, wasn't the featureless void we thought it was. Instead, it seemed to be filled with regions of varying densities, temperatures, and energy levels. Some areas were dense and hot, while others were sparse and cold. These regions, which scientists dubbed plasma clouds, were linked to ancient supernova remnants, suggesting that the interstellar medium had been shaped by violent cosmic events that occurred millions of years ago. This discovery has profound implications for our understanding of the cosmos. The interstellar medium is far from a smooth, uniform expanse. It's a dynamic, complex environment, shaped by the violent history of our galaxy.